Now today we are discussing the 12th level chapter. The chapter name is differential error and approximations. Differential error and approximation. In this chapter, at first we are giving some introduction about this chapter. After that we are giving differential, then we are giving geometrical significance of differential, then next topic we are discussing the error. And there are three types of error is there. Absolute error is there, relative error is there, and percentage error is there. And three error will be discussed in later ones. And after that, that is the last sections, we are giving some example about this chapter. Now at first we are discussing the introduction. In the introduction sections, suppose y is equal to fx is a given function and delta x is a small increasing of x and delta y is also a small increasing of y. Then we can write limit delta x tends to 0 delta y by delta x, and it may be expressed as dy by dx. And now this is the introduction of this chapter of differential error and approximations. Now we move to the next part, that is a differential. Now in the second section, that is a differential section. In differential sections, now at first in the differential section, at first limit delta x tends to 0 delta y by delta x is equal to dy by dx, and this is f dash x. From this we can write delta y by delta x is equal to f dash x plus of epsilon. Now epsilon is a positive small quantity. Now epsilon is tends to 0 if delta x tends to 0. So by multiplying we get delta y is equal to f dash x into delta x plus epsilon into delta x. Since this part delta x and epsilon is a small number, we can ignore this part. After ignoring this part, we can write delta y is equal to, this is the f dash x is equal to dy by dx. We are using here multiple with delta x, and this formula has a unique name. The name is linear approximation formula. This is the linear approximation formula. Okay, we move to the next, that is the geometrical significance of the differential. Now the geometrical significance of differential is, here we are giving a simple diagram to understand this section better. Now according to the diagrams, there is a point P, the coordinate of P is xy, and the other point is Q, and the coordinate of Q is delta x plus x comma delta y plus y. That is the delta x delta y is a small increasing. If Q tends to P, that is Q gradually approaching to the P, then delta x, this is a delta x tends to 0, and in that sections we can write delta y by delta x is equal to dy by dx. And from the diagrams we can see this is the angle, and this angle is called psi, and this is theta, and this angle also psi, this is a symbol of psi. Then we can write by the diagram tan of psi is equal to dy by dx. This is the geometrical significance of differentials. Now we move to the next part, that is the error part, and we are discussing the three error of our discussion. In the next part of error section, there are three types of error is there. One is absolute error, second is relative error, and the third is percentage error. And absolute error is, in this section, absolute error is delta x. That is delta x is called absolute error of x. And delta x by is called relative error of x, and delta x by x multiplied with 100 is called the percentage error of x. And this is the error section is completed. Now we move to the next section, that is the example sections. This is the last topic of today's discussings. Now first example, we are finding d of xy and d of x square by y and d of tan inverse x and d of x by y. Now for d of xy is the formula of d is a formula of x dy plus y dx. First is completed. Now the second part, that is d of x square by y is equal to y square y into d of x square minus x square into dy. Now the third part, that is d of tan inverse x is equal to 1 by x square of dx. And now d of y by x is equal to this one, that is y into dx minus x into dy divided by x square. So d of xy is equal to x dy plus y dx, and d of x square by y is equal to y into dx square minus of x square into dy divided by y square, and d of tan inverse x is equal to 1 by 1 plus x square multiplied with dx, and d of y by x is equal to y into dx minus x into dy divided by x square. This is the first example of our discussions. Now we have moved to the next example, that is the last example of our discussion. Dear student, subscribe the channel. Dear students, subscribe the channel for more information about class 9, 10, 11, 12 and competitive exam also. We are present this chapter as a simplest way to you to understand this chapter better. Okay, we move to the next example, that is the last example of the day. Now the last example of the day is find tan 44 degree when 1 degree is equal to 0.0174 radian. Let fx is equal to tan x, then d of fx is equal to derivative of tan is equal to sec square x into dx. We know that f of x plus delta x is equal to f of x plus f dash x into delta x. Here x is equal to, if we take x is equal to 45, then delta x is equal to minus of 1 degree, that is minus of 0.01745. Now putting this value, we get f of 45 minus of 1, then f of 45 and f dash of 45, and putting the delta x is equal to minus of 1 degree. Now further we putting this one, that is f of 44 and f of 45 degree and f of 45 degree multiplied with minus of 1 degree. Now using here, that is tan 44 degree is equal to tan of 45 degree and there is f dash x means sec a square 45 degree and multiply the putting the value of this one. Now further putting this the value, we know that the tan 45 is equal to 1 and sec of 45 is equal to 2 and this is a square and multiple with minus 0.01745. After calculating we get so and multiply it 2 then minus after calculating this we get the value of tan 44 degree is this one, which is our equal, that is a tan of 44 degree is equal to 0.9651 approximately. Hope the given information and example will help you to understand this chapter better, and when you practicing this chapter then this video will help you to understand this chapter better.